Hello, this is Nikki Jackson, one of the adjunct instructors for Concord College, and here are examples from homework in Module 4 for Math 1320 College Algebra. Before we get started, let's have a better understanding of the due dates and how to access your assignments online. Module 4 is already available to you, so right now you need to go on Module 4 and complete the overview so that you may be able to access your homework. Now be mindful, it's very important for you to check the Remind app in your email quite frequently for any changes. At this time, even though everything is available online, you will be required to come to class virtually, meaning that I need you to log in on Tuesday, which is going to be March the 24th. And I'm getting more and more information and I'm going to share it with you as required among. Now, since most of the stuff actually has to be done away from campus, notice the dates right here from March 31st. It's going to be the same time frame as we normally would take your exams. So things will be open to you virtually, but I still might need you to actually log in during the same time. So we will be using Canvas quite a bit for our discussions or our chats. And I also might need you to download Microsoft so we can do a team, so that would be a virtual. The best bet probably would be us using Zoom, but again, if we actually have to see each other, I will have to let you know what the best way to do that. So the Remind app is the best way to communicate with me, and I will send emails again. Don't hesitate to ask questions, but just give me enough time to actually reply, especially on the weekends. I tend to reply quicker to the text messages than I'm doing the emails, but I want to make sure that everybody is aware of what's going on. So again, check the Remind app in your emails. So for right now, let's go ahead and get started with these examples. I request that you actually have pencil and paper available right now, along with the graphing calculator that I asked you to download during the first class session. Here's your first example. Unfortunately, the video is not closed caption, so please feel free to pause or rewind so that you can have a better understanding of this. When it's your turn to do it on the computer to submit your homework, be careful on how the steps. You may even want to have dual screens, so have two different screens open up at the same time. One could be the video and the one could actually be the homework. But nevertheless, we still have to make sure that we complete these within the due dates. What homework 4 is pertaining to is dealing with a system of equations. Now this is considered a system of equations because you see that you have two variables, which are x and y, and you also have two equations themselves, hence the equal signs. There are multiple ways to arrive at this answer, so the first way I'm going to show you is how to do it by hand. As previously stated, this is a system of equations where there are two equations, hence the two equal signs, and your two variables, x and y. The first way that we're going to solve is solve by elimination. I want you to notice when you do that, that you actually have a negative y and a positive y. That means these two y's will cancel each other out if you were to combine your like terms. So it's slowly moving the paper up so you can see it. The cancellation of the y is the same thing about elimination. So notice how the y's cancel right here on the top when you combine your like terms. So this one on top is your negative, and that one right here is going to be your positive. When you combine your like terms, 1 plus 2 is 3x, and then 2 plus 10 gives you the 12. To isolate the variable for x, you got to divide both sides by 3, therefore your x equals 3. So once again, the first step is combine your like terms, and then you have to solve for x. Take a moment to pause your video so you can have a better understanding of what we did to isolate the variable of x. Now we're going to substitute your x into the first equation that was given. Your first equation was x minus y equals 2. So since we said that x was 4, 4 minus y equals 2. To isolate the variable of y, you're going to do the opposite of a positive, which is negative. Therefore, you're going to subtract 4 from both sides. So you're solving for y. Bring down your minus sign, bring down your y. 2 minus 4 gives you negative 2. Remember, like signs you know you add, unlike signs subtract. Take the sign of the greater number, then you'll be exact. So if you ever get confused with your integers, I strongly suggest that you use your calculator for the sake of time. Now you have negative y equals negative 2. Well, this is the same thing as saying negative 1y. So now you're going to divide both sides by negative 1. Once you do that, you have y equals 2, because two negatives give you a positive. Your solution set is 4 and 2. So be careful when you write it down that you actually write it as an ordered pair. Because I've noticed in the past when we're doing this, it sometimes tends to make an error. Now the other way is to use solving matrices. If you go back into Canvas and look under Module 4, one of them should say dealing with how to solve system of equations. Those are step-by-step PDF files of showing you how to use your calculator. Now of course the video is going to show you how to do it too, but just in case you get confused or need additional references, it's already posted under Canvas for Module 4. Now, here's with the matrix, and we're not talking about the movie. What a matrix is similar to what a system of equations are, except you're doing it by row and column. So right here we have 2 rows, which represents your 2 equations. Then you have 3 columns, which represent your x values, your y values, and your constants. So now we have the 2 by 3 matrix. Now we're going to rewrite it in matrix form by taking all of your coefficients. So before I move it too quick, notice how you have 1 x and a negative 1 y, then a 2. Then you have a 2x, a positive 1 y, and a 10. So when you rewrite it, it looks like this. When we use the calculator, we're going to use reduced row echelon form. But before I show you how to use the calculator, make sure you write this down. So once again, where that came from was your system of equations. You're looking at your coefficients. So you have 1x, negative 1y, then 2. Then you have your 2x, your positive 1y, and your 10. It's very important for you to write this down first, because that's what we actually have to input in the calculator. So here's the calculator. First you're going to hit second, then matrix. So hopefully you can see my fingers. Then you're going to go down. Use your right arrow key, go to edit. Hit enter. Now remember, this was a 2 by 3 matrix, so you're going to hit enter for 2, then type in 3, then hit enter. Your numbers were 1, negative 1, and 2. Notice how I'm going in a row. Your next number were 2, 1, and 10. Then hit enter. So now you have your 2 by 3 matrix. Hit second, then quit. Second, then matrix again. Use your right arrow key, go to mouth. Go all the way down until you see RREF. Not REF, but RREF. That represents reduced row echelon form. Hit enter. Second matrix. Hit enter again because you're only using the one matrix. Hit enter. So look at this new matrix that you have. Notice how you have a diagonal of ones right here, and then you have the zeros right there. But this last column, which goes up and down, represents your solution set. So your x would be 4, your y would be 2. Now I know that was quite a bit that we just did with the matrices, or several other examples will make you feel a little bit more comfortable in it. And again, a PDF file for how to use your TI-83 and TI-84 is already posted in Canvas for Module 4. Here's another example of a system of equations. Now, pay close attention to this. We're not going to use any other type of method to do it because notice how your x's can't cancel each other out, nor can your y's. So we're going to resort to the calculator for this. First thing we're going to do is figure out how many rows and columns it has. So it has 2 rows and then 1, 2, 3 columns. Here's a quick summary of how we're going to input it in the calculator. So here are your initial equations. Then we're going to rewrite it as a matrix using your coefficients. So we have 5, negative 1, negative 48. Then we have 2, 3, and negative 9. Once again, you're going to input it as a 2 by 3 matrix. And then we're going to solve it using RREF command. So hit clear in your calculator. Then we're going to hit second, the matrix. Use your right arrow key, go to edit. Once again, we're going to make this, hit enter. It's already a 2x3 matrix, so make sure that you hit 2, enter, and 3. Input your new numbers now, which would be 5, -1, -48. Make sure that you know that this right here is not the negative sign. Your negative sign is going to be down here at the bottom of the lower right hand corner. I'm not quite sure if you can see it or not without the glare, but that's where it's going to be. Your next row is going to be 2, +3, -9. So hit enter to confirm it. Hit second mode. Now this step right here is not necessary, but different people have different versions of the calculator, so it's best to just exit out of it completely. Next, do second matrix again. Notice how it says matrix right there. Use your right arrow key. Now use your down arrow key until you go to RREF. Hit enter. Second matrix again. Hit enter. Hit enter one more time. Notice the last column. So your X value will be -9, your Y value will be 3. So if you entered it as an ordered pair, it'd be -9, 3. Here's another system of equations. Now, of course, I'm going to show you how to do the calculator way, but notice how it's not in standard form. So right now, we're going to use what we call the substitution method, which is stated right here. The reason why we're using substitution, because it clearly states that y equals 4x minus 16. So in the second equation, wherever you see y, you're going to replace 4x minus 16. So again, we're going to solve by using substitution. For the second equation only, we're going to substitute the first equation. Hence why you see those parentheses. Right here, you're going to combine your like terms, because 7 plus 4 gives you 11. Bring down the 16, bring down your 28. Since we're trying to solve for x, we're going to subtract 16 from both, add 16 to both sides, because that's the opposite of subtraction. So now you have 11x equals 44. Now divide both sides by 11, you know that x equals 4. Now we're going to plug it into the first equation. So going back to your first equation, which was y equals 4x minus 16, we're going to substitute x as 4. So 4 times 4 is 16. Bring down your minus 16. 16 minus 16 is 0. Therefore, y equals 0. So your solution set as an ordered pair would be 4, 0. Now, it might be a glitch in the video, so hopefully you can see this right here. But now we have it both written in standard form. Next, you're going to write it as a matrix. And this is going to be a 2x3 matrix, which is the -4, 1, -16, 7, 1, and 28. Then you're going to find it as reduced row echelon form, which you're going to be in the calculator. Now notice the last column, which is 4 and 0. Now in just a moment, I'm going to show you how to input this into the calculator. We're going to follow the exact same steps that we used earlier. So once you cut it on, hit clear. Second matrix, use your right arrow key, go to edit, hit enter. It's still a 2x3, so make sure you lock that in by hitting enter. The numbers that you're going to input now will be -4, enter, 1, enter, -16, enter. For your second row, it will be 7, enter, 1, enter, and 28. Oops, I made a mistake. Now as you can see, I've already made a mistake. Instead of saying the 2x3, I said 2x2. So now I have to go back in and make my corrections. Which is good that I made a mistake, because now you know how to go back and do it as well. It's just like texting. You just have to use your up and down arrows to make any corrections. Now that I have it inputted correctly, hit second mode, second matrix. Use your right arrow key in the map, and we should be going down once again to RREF. Hit enter, second matrix. Hit enter because I only want you to use one matrix so you won't get too confused. Sorry about that glare. Enter. Notice your last column is going to be 4 and 0. Of course, we had to give you a word problem. Here's a word problem also dealing with a system of equations. Make sure that you read it carefully, so you might need to pause the video. But your system equation is going to be based upon the money and the number of rooms. So once again, make sure you pause it to read it. Notice that you also have your answers as well for which one is what. So you have your single rooms as 11 and your double rooms as 19. So note how I said read the problem carefully because this is a system of equations. Your first equation is going to be pertaining to your money. So it was $35 per room for a double, and then it was $25 for a single, which was a total of $940. It's kind of faint right here, but the D stands for double and the S stands for single. Your second equation was dealing with the number of rooms. So you had your doubles plus your singles equals your 30. So again, this is a system of equations. Hopefully you can see the different colors, but now you know that this is going to be a 2 by 3 matrix. So we're going to use your calculator solving by 2 by 3 matrices where you have 35, 25, 940 for the first equation, 1, 1, and 30 for the second equation. Your X in this case is going to be your doubles, and then your S is going to be your Y, which is going to represent your singles. So let's put it in the calculator. So hopefully you're following along with me. So I'm going to hit clear. Second matrix. Use your right arrow key, go to edit. Hit enter. Once again, it's still going to be a 2 by 3. Now input your numbers. It's 25, enter, 25, 940. Now periodically you're going to hear me say the word enter, and the reason why I'm saying that, you have to hit enter to lock your numbers in. Once you hit your 2 by 3, have all the numbers input, hit second mode, second matrix. Use your right arrow key to map, go all the way down to RREF, enter, second matrix again, hit enter, enter one more time. Notice how you have your diagonal for your ones and everything else was zeros. Your last column is 19 and 11. But you have to be very careful on what is what now. Especially when it's your turn to put it in on the computer. So this is what we just did, and this is what we have. Remember, your X is going to be your doubles, your Y is going to be your singles. So you had 19 double beds and 11 singles. Notice how we had the exact same answer when we did substitution as well. It might be kind of frustrating and boring right now, but it's going to get a little bit better, especially when we get closer and closer to the end. Your next example is still dealing with the system of equations, except it's getting larger. With this particular system equation, it's going to be a 3-row and a 4-column. Now, because of the complexity of this, I'm not going to show you how to use substitution because we literally have to solve for 3 different variables. So, for the time purposes, we're going to use this in your calculator. Now, if by any chance anyone wants to know how you're going to use this in real life, in the medical field, I'm not really sure in regards to research, you will have to do it. For right now, a prime example would be the number of variables that will affect the coronavirus while they're creating the vaccine, because you have so many different variables that affect it. So in this case right here, you have 3 different variables that might actually affect it. That's one way. Now otherwise, I'm not really sure, but I do know how to use it in, linear algebra because that's dealing with engineer. But we're not engineers yet. Nevertheless, let's get back to the problem and figure out how to put this in the calculator. So here goes the example written as a 3x4 matrix. And of course, I've already showed you how to, write it in reduced row echelon form. Again, notice how you got your diagonals of ones. Take note to the last column. So X would be 8, Y would be 1, Z would be 4. But let me show you how I actually got this one. Now you might actually have to pause or either do your dual screens to figure out where I got those numbers from. But that was dealing with your X's and your Y's and your Z's. Now to input it in the calculator, make sure it's on. Hit second matrix. Use your right arrow key. Go to edit. Hit enter. Now we have to do some changing now. The changes that are going to occur right now mean that it's going to be different dimensions. Those dimensions are now going to be 3. Make sure you hit enter, then 4. Let's input our numbers now. We're going to have 1, -2, 3, 18 for the first row, 2, 1, 5, 37 for the second row. And then for your last row, it would be 3, -4, -2, and 12. Again, I know I'm going kind of fast because the videos can only be so long, but you're feel free to pause and actually go back and rewind this. Secondly, we're going to hit second quit, second matrix. Use your right arrow key to go to math and go down to what? Reduce row echelon form. Told you first. Repetition makes it a little bit easier. Second matrix, hit enter, enter again. Voila! You have your last column and then you have your diagonal of ones. Now when it looks like this, when you have all these ones and zeros, no, that's not binary code in this case, but it's considered reduced row echelon form because only that last column is going to give you your solution set and everything else should be 1 and zeros. Now with that being said, let's look at your next 2 examples for your homework. So here they are right here, your actual numbers. Pay close attention to each one of them. Notice how both of them have answers of no. So what I'm going to do in just a moment is rewrite them and show you why they're no. So for the first matrix, you do have your diagonal of ones. But remember what I previously said, everything else except that last column should be zeros. Well, that's not true. You got a 1 and a 9 right here. Now you're looking at your second example. Dude, it's going to shimmy its way on in there. It has it should have a diagonal of ones, but it doesn't. Those are ones and zeros, but the zeros are in the wrong place. The 1 should be a diagonal right here where everything else should be zeros. Even though that last column is correct, all of this should be 1. So that's also a no. Here's another example of a system of equations. Now this is quite a bit right here because you have 1, 2, 3, 4 equations and you have to literally solve for 1, 2, 3, 4 x's. So just imagine how to do this the long way. But of course we're not going to do that. We're going to use that handy dandy calculator. So this one right here is going to be a 4x5 because you have 1, 2, 3, 4 rows and 1, 2, 3, 4, 5 columns. Notice how the answers are already given to you, so you know your answers are automatically going to be in your last column of your matrix. So what I did was rewrite as a 4x5 matrix using all the coefficients. That's not even a word. And then I used my calculator solving reduced row echelon form. And again, the last column gave me the same thing. But now I'm going to show you how I got from here to here. Notice how you have your diagonal of ones. So I got my handy dandy calculator and it is on. So second matrix, go over to edit, hit enter. Sorry about the glare, so let me bring it down just a little bit so you can see it. And zoom in. Ta-da. We're going to make this a 4 enter by 5 matrix. So our numbers are going to be inputted as you see them. So it's 1, -3, -2, 1, -4. I'm going to go ahead and do this like fast forward so you can see exactly what it's going to do because of the sake of time. And like magic, the numbers are already in there. Again, as I previously stated, I just paused it and jumped ahead of you guys because the video can only be so long. But nevertheless, we got them in. We're going to hit second mode. Hit second. Let me push it up a little bit. And then your matrix key again. Go over to math. Use your down arrow key until you go to reduce row echelon form, which is RREF. Hit enter. Second matrix again. You only have one matrix, so hit enter. Enter again. And wow, look at that. Look at that last column. Once again, you know it's in reduced row echelon form because everything outside of that last column are ones and zeros where you have a diagonal of ones. Here's another example. It's already given to you in reduced row echelon form because I'm looking at the ones and zeros and I got a column of ones. So you don't have to put this in the calculator. And make sure that you read it carefully because it's asking you to find x1, x2, x3, and x4. Well, that's kind of easy because you know that your x1 is going to be -5. Your x2 is going to be 1. Your x3 is going to be -5. And x4 is going to be 0. So let me zoom out just a little bit so y'all can see that. So what you're doing is looking at the last column. That last column is also your solution set. It would be cool if all your numbers or answers or problems would be just like this, but it's not. Which leads us into number 10, your next example. So this particular one is already given to you as a matrix, but it's asking you to find the determinant. Notice how this is a 3 by 3 matrix. Once again, it's a 3 by 3 matrix. So let's figure out how they found the answer of 48. Again, it's looking for the determinant. So we're going to use a calculator as a 3 by 3 matrix, and we're finding DET, which stands for the determinant. Let's put it in the calculator now. So here goes my calculator. I'm going to hit second matrix, go over to edit, hit enter, do 3 by 3, enter. Now let's put our numbers in. So your numbers are going to be inputted as you have them listed. So now you have your 3 by 3 matrix. Hit second mode, then second matrix. Use your right arrow key, go to math. But stop now. We're so used to doing RREF, we don't need to do that now. We're simply trying to find the determinant. The determinant is the very first option. So hit enter, second matrix again, select your first matrix, so hit enter, then hit enter again. Now it's saying that the answer is 78 and we got 48. So let me see what mistake did I make. So somewhere I put in the wrong thing. So we had 1, 3, -2, -2, 1, 1, then 5, 6, 5. I guess I did that right or wrong. I'm not really sure. Did I write my numbers right? I did not write my numbers right. Haha. I found my mistake, y'all. That was supposed to be a -1. It looks retarded right now. It has a little swag to it. So let's make that mistake correction real quick. So second matrix, edit, still 3 by 3. Remember, it's just like you texting, so you can use your arrow keys over here. So I'm going to make that a -1, enter. Second mode, second matrix, go to math, hit enter for DET. Second matrix again, hit enter, enter again. Voila, got my 48. So again, my apologies. I know I was going kind of fast right there, but please pause if I'm going too fast, or either just rewind. But you just see that I'm human. I make mistakes all the time. But hopefully you'll be able to, correct me in advance and see what I did wrong. If not, that's okay. We're human too. We all make mistakes, and we're gonna learn this together, y'all. Mentioning learning together, we got one more example dealing with the homework. It's very similar to what we did with the remaining problems. It does indicate using the Kramer rule. We're not going to use that. Of course, we're going to use our what? Handy dandy calculator. This is a 2x3 matrix because you have 2 rows and 3 columns. It already said that the answers were 1 and 7, so your x is 1, your y is 7. So let's input it in the calculator. Alright, awesome sauce, we got that. So we're going to do second matrix. Go over to edit. Make it a 2x3. So your numbers are your coefficients. So that's going to be 2, -1, -5, 3, 2, 17. Hopefully I won't make a mistake this time. Second quick, second matrix, go to math, go down to RREF, hit enter, second matrix again, enter, enter, voila, x is 1, y is 7. So overall, here was your 2x3 matrix. Here it is as reduced row echelon form, and your final answer or your solution set is 1 and 7. So thank you for your patience and understanding with this video example or lecture. Right now we're not physically meeting, but please be patient. I'm sure that this too shall pass, and hopefully these examples and video helps. If you have any questions or concern, feel free to email me or use the Remind app, and hope to see you soon. You guys be safe and continue to work diligently.